So we've talked in previous videos about both stacks in general, as well as implementing stacks using arrays. In this video, we're going to talk a little bit about using linked lists to overcome some of the limitations that you have by using arrays for stacks. In particular, we saw that when you use arrays, you can actually fill up the stack and can't add anything else. Arrays are nice and easy to use, obviously, but they do have that limitation. So just a quick reminder of what stacks are. So stacks are a data type that store a collection of elements. So it allows you to access the very top of the stack, right? We can access the top of the stack, and we can either push stuff on top of it or pull out the top thing, right? We don't really have access to the rest of the stack, right? You can only access that top thing. And we can check whether it's empty, get the length, look at that top item without taking it out, right? So when we implement stacks using a linked list, we're going to have this stack class, and then you're going to have a linked list that we call top that's going to store all of our data. It's going to store our collection of data. So in the previous example, when we were using arrays, this would have been an array. I think we called it A, right? And it would have had a pointer to the top. Here we just have a pointer to a linked list, and initially that linked list is empty, so top is null, right? There's no items in our stack, so top is null. And what the stack is going to do is it's going to, as you push things into the stack, we're going to add them to the front of the linked list. So the first thing goes in, right? And you put it at the front. Its next pointer is null. If we add, say, 2, then now 2 points to 1, 1 points to null. Same thing with 3, 3 points to 2, 2 points to 1, 1 points to 0. Notice that it's very easy to access the front or the top of the stack, but it's more difficult to access the rest of it, and really we shouldn't be able to, right? So that's pushing onto a stack using linked lists. If we want to pop from the stack, it's also pretty straightforward. Basically, we take that top element, right? We return the front element, update the top pointer to its next pointer, right? And now our structure is a stack that's slightly smaller. Same thing if we pop out 2, if we pop out 1. And then the stack is empty when the top is null, right? So we saw that at the beginning when we initialized the stack, there was nothing in it. Top was null. Now we've emptied the stack, and it's once again null, right? As I mentioned before, with linked lists, the stacks can't be full, right? I mean, you can eventually run out of main memory, but that's going to be very far into the future, right? But we don't have to define sort of the limit on the size of the stack like we did with arrays, right? But here, counting the number of elements in the stack is a bit more complicated. So with an array, we simply returned the value of top, right? Because it was just an index into the array. Now we actually have to count the length of the linked list. So we know at this point how to count the elements in a linked list. You set up a pointer and a counter, and every time you increment the pointer, you increment the counter until you get to a point where your pointer is null and you have the count. So we can do it quite easily, but it's a little bit more work than it was when we were using an array. So there are pros and cons to both arrays and linked lists. So here you need to make a linked list class, right? But they sort of come at the expense of other things.